rolling. Please stand. And let us pray. In the name of the Father, and of the Son, and of the Holy Spirit. Amen. Remember, O most gracious Virgin Mary, that never was it known that anyone who fled to thy protection, implored thy help, or sought thine intercession, was left unaided. Inspired by this confidence, I fly unto thee, O Virgin of Virgins, my Mother. To thee do I come, before thee I stand, sinful and sorrowful. O Mother of the Word incarnate, despise not my petitions, but in thy mercy hear and answer me. Amen. In the name of the Father, and of the Son, and of the Holy Spirit. Excuse me. Okay, take out your notes, please. Yes. What's up, sorry? Yes. Yeah, that I'm trying to get as hot in here as humanly possible. So, yeah. If it gets too hot on that corner, let me know, but I don't think it's very likely. Are you feeling a little? Yeah. Oh, I'm sorry. I can move it. Yeah. Yeah, I don't want to be a little gross. Wow, how am I going to do this? That's what I was doing. Let me know if anybody gets chilled, but it's blowing the heat your way. So, God willing, it'll work. Welcome to my world. All right. In your notes, please put down the following. F of x equals x cubed minus x. And g of x is equal to, let me see, f of x minus 2 plus 3. What I'm going to do is give you the graph of the first one. It's kind of an unusual graph. We would be playing with it once in a while. I will have you tell me a few things. Can anybody find any points on that graph whatsoever? Like if I just threw a random function at you and said, hi, here's a function, graph it. Where would you even start? Yeah.
The y-intercept 0.
Yeah, you can find the y-intercept, the x-intercept. How do you get a y-intercept again?
Oh, plug in 0 for x.
Yeah, y-intercept is where x is 0. What does that give you?
0.
Yeah, y equals 0. So I at least know there's a point 0, 0. Okay, let me find another. Did we do this one yesterday? This is seeming kind of familiar. Maybe I did in calculus. What else can you find? What other unique points of interest might be used? Courtney, we found y-intercepts. What else could we find? How do you find x-intercepts? If y equals 0. So it looks like this. I don't see a y in here though. Where is it? Yeah. Yeah, f of x and y mean the exact same thing. You can always swap them. Y equals means you're graphing. F of x equals means you're treating it like a function. So y equals x cubed minus x becomes 0 equals x cubed minus x. So how do you get the x-intercepts on that one? Mary, take over. How do you solve that? You can factor out an x, GCF. So x parentheses what? Does that factor? Like what? Close. Binomial squared is square the first of difference of two squares. So what is it?
X plus 1, x minus 1.
Good. X plus 1, x minus 1. And what solutions would you get?
X equals 0. X
0.
equals -1, X equals 1.
Correct. I'm looking really familiar. Sure we didn't do this yesterday? I'm having deja vu. You won't kill me. So we got 3 solutions, 0, -1, and 1. That means I've got 3 x-intercepts. One of them was already there because it was also the y-intercept. Right here. What does this graph look like? I'll tell you 2 more points. The way you can graph pretty much anything, if you don't know what shape it is, and this is kind of mysterious, we haven't graphed cubics, degree 3 things very much, is use the table. Plug in a few negatives, plug in a few positives, plug in 0, and see what happens. Now we got these. I got 0, 0, and 0, which wasn't all that useful. Can somebody calculate plugging in positive 2, for example? Katie, help me out here. Just into this thing.
So it would be 6.
Yeah, it's 8 minus 2, which is 6. Austin, give me -2 plug in.
That would be 6.
I'm sorry?
-10. Nope.
Sort of, kind of, other direction.
-6.
Plug in first. What's -2 cubed?
-8.
-8. And then -2.
Plus 2.
Plus 2.
6.
What's that?
-6.
-6, okay. So we've got -2, -6. I'm going to do this. Why I'm cheating? Because I don't want to draw all the little dashes. And I also looked at the function earlier, so I know I plugged in a bunch of 1/2s and things like that to find this. You kind of a neat looking graph. That's a graph of what we call a cubic. Something with degree 3 usually has this sort of characteristic swoop, up, down, up. If it's a negative cubic, it would be down, up, down. It would be upside down. But that's sort of, it's kind of graceful. It's sort of up, down, up. It sort of waves at you as it goes back up, up to infinity. My question is this. Can you graph this? I don't even have a formula for it. I can show you how to get the formula for it, but I don't think you'd thank me. But you don't need the formula. Can somebody tell me how to graph this new beast? You notice it's based on the function f of x. What did they do to it? They did change it somehow. Tell me how. Go.
It's like they raised it up 2 spaces and then moved it to the right 3 spaces.
Yeah, this is a move. It's an input move because it's inside the function. Input does the opposite of what you expect. So this is going to the right 2. And it's going what?
And then right 2, then
Up 3. Because this is a move on the output because it's outside the function. So whatever on earth this thing is, it moved to the right 2 and up 3. Take your previous one and do that. The easiest one to move is this, at first, is the center. So 0, 0 moves to, actually Abby, take this one. 0, 0 is going to move where? Like physically, where does it go? To the right 2. And
And up 3.
and up 3. Your new center point is at 2, 3. It's not at 0, 0 anymore. Move the other points if you'd be so kind. Mary Claire, take over. This is kind of the same as this one. So I tell you what, I'll even label them. There's A, B, C, D, E. And if you remember the other day, I'm going to call this C prime. It's the new C. Go ahead. Whichever one you like. Pick one. A? Okay. Where is it right now, first of all? What come of what? One little thing for the 2.
Or -2.
-2, -6. So where does it go now? 0, 0 comma something, comma what? Yeah, and it goes up 3, it'll get up to negative 3. Does that make sense? So 0 comma negative 3. This is going to be A prime. In other words, just count where this is, and then move to the right 2 and up 3, just physically. Let me see. Megan, take B. Tell me where B prime would be. No pun intended. Where is it now? Negative 1, 0. So where should it move? Yeah, 2 to the right, and then a what? Correct. A shorter way to do that, and there are like 10 different ways to do this. If you notice that B is just one space directly to the left of C, you do the exact same thing here. Sam, take over. Give me D prime.
If you move over to that 3,
3 comma 3, correct. And another way of thinking of that is just one space to the right of C. And then E prime, Josh.
also move over to, so go from
Yeah, it started at 2, now we're going to go to 4. 4 comma what? 4 comma 9. 4, 5, 6, 7, 8, 9. There's E prime. And then you notice how this sort of did this graceful up, down, up? That's exactly what's going to happen here. So they should be able to give you any graph on Earth. As long as they give you some points, you should be able to give you the transformation graph. If they say, have I moved up 5 or to the left 3 or flip it upside down or something like that, you should be able, with a little bit of detective work, to get that. Does that make sense? Is that right? I want to talk, there are 3 things I want to cover today. That was 1, so there are 2 more. The second thing, you might have seen this before. I want to talk today about something called an inverse function. An inverse function. Now a function, does anybody remember what a function is? A function has a specific, you can define it with 5 words. What's special about a function? Go. One input yields one output. If you plug one number in, you should get one number out. So again, a function, one input yields one output. That's a definition of a function. What is an inverse function? Well, let me show you the notation first. The inverse of f of x is written like this. F with what looks like an exponent -1 of x. That's the universal notation for inverse function of f of x, or inverse of f of x. Okay? This thing, the story as I understand it, when math was being developed, I mean, there was a point in time, believe it or not, when algebra really did not exist. People had to invent it, they had to stumble over it. There was a time when trigonometry did not exist. Sine, cosine, tangent, that came in the late Middle Ages and the Renaissance era, 1400s, 1500s. It didn't, maybe even a little later. Calculus did not exist until the 1600s. Sir Isaac Newton and Gottfried Leibniz and whatever the other guy's name is, I can't remember off the top of my head. But this symbol, there's one group of mathematicians in one part of the world, I don't know if it was Asia or Europe or what, exponents did not exist. Pain in the neck at that point, I'm pretty sure. If you wanted to do 2 times 2 times 2 times 2 times 2, 30 times, you just had to do it by hand. And if you wanted to do a notation of like, what is 2 multiplied by itself 30 times, is there a short way to write it? No, unless you invented one for yourself. And then you had to go tell everybody, by the way, that's my private notation for 2 times itself 30 times. And they might have, you know, it could have been anything. It could have been like 2, to the, let's say, smiley face 30 above it or something like that. If you're inventing your own, it could be any goofy thing you want. The idea of putting a tiny number in the upper right-hand corner didn't show up for quite a long time. So that was a new invention. It's called an exponent. We're used to it. But hundreds of years ago, it didn't exist. In one part of the world, they discovered exponents. There was great rejoicing because 2 to the 30th power, you didn't have to do anything dumb like this, and it was a nice short way of writing it. In another part of the world, people were working on inverse functions. They had absolutely no clue that people in the other part of the world were inventing exponents. They decided to put this, they only use -1. They don't use -2 or -5, or this is the only number on earth they do for inverse. And I'm sure they were very proud of their invention. 50 years, 100 years go by. Some mathematicians from one part of the world start traveling and meet mathematicians from the other part of the world. And they finally got a translator or something and started talking to each other and said, oh, we have this great invention. It's called an exponent. This is, 2 to the 5th power. It means 2 times 2 times 2 times 2 times 2. And I'm sure the other group goes, wow, that's a great thing. We've been doing this smiley face thing. It looks dumb. I made that up. But, they were doing something that was long and clunky. So this is a very elegant thing. And they said, oh, and you can use 2 to the 0 power too. I remember what 2 to the 0 power is? It's 1, yeah. You can also use it with 2 to the -1 power, which by the way is 1/2. At that point, these people from the other part of the world get a really long face. What's wrong? Isn't this exciting? 2 to the -1 power. It's kind of like 1 over 2 to the 1st power. Isn't that great? 2 to the -3rd power is 1 over 2 to the 3rd. And they're saying, yes, that is very exciting. Yes, that is very exciting. We are very happy for you. Do you realize you have just stolen our notation? What? This is our notation for the inverse of the function of the f of x. What are you doing with the thing in the exponent? How about you use all the other exponents except the -1 because we already use this. Thank you very much. No, we did it first. No, we don't do it. We going to fisticuffs over this? I don't know what exactly happened. But the way they settled it was they decided to use both. This leaves us with a little bit of confusion in the modern times because if somebody sees this, what does it mean? It really depends. If they're trying to have this as being short for f of x, then that's a function inverse. Because they only exist on functions. But if they're doing like this, where this is not a function, then this is 1 over x. So they just agreed to use both of them even though they look the exact same thing. It's kind of like having 3 of your kids and you're naming them all John Barker Anderson, John Barker Anderson, and John Barker Anderson. That's cruel. Okay, you're John Barker Anderson number 1 because you were born technically 30 seconds earlier. Seriously, this is confusing. Does it make sense though? The only time this ever means inverse is when it's on top of a function. If it's on top of a variable or number, it's exponent. I apologize on behalf of all the weird mathematicians of the world who set us up with this confusion, but I was not even born by the time this was done, so don't blame me. Now that the story's out of the way, what is an inverse function? An inverse function cancels f of x. That's its purpose. What does that mean? In other words, for example, if you were to have f of 3, like I don't even know what the function is, and you get an answer of 10, it could happen. It could be x squared plus 1 or something. The inverse function undoes what the first one does. The first one plug in a 3 and you get out a 10. The inverse function, by the way, there's another word for inverse. Reverse. It goes backwards. It undoes what the other one does. So basically, if you plug in a 10 into the inverse, guess what you get out? Okay. Great. Does that make sense? It just is, it's a backwards version of the machine. So how do you get an inverse? Now, you might be wondering, who cares? Why would you ever be playing around with an inverse function anyway? Well, I'll answer that in a minute, or 5. But for right now, I want to show you how to get it. How do you get an inverse function? To get f inverse of x, we've actually seen it before, that's the good news. You trade x and y. There's a little bit of logic to that too. Because you notice this is 3 is the input and 10 is the output. You swapped them. Now 10 is the input and 3 is the output. You have just automatically done an inverse. Just by swapping x and y, you've created an inverse function. And by the way, does everybody recognize that? A reflection over what? Wait a second. Nate? Just occurred to me. Sorry, Nate. Hope you're feeling better. I'm just so used to you being here, and then Sam took your place. So anyway, reflection over what? Yeah. Over the line y equals x. That's why we were playing with them so much yesterday. Why we were saying like there were loads and loads of problems over and over and over saying let's reflect over the line y equals x. Because you're actually doing something interesting. You're making an inverse. Let me show you what I mean. And let me prove it to you. Got some extra space here. Suppose for the sake of argument that you have f of x equals 3x plus 2. Okay, now that's pretty much the exact same thing as saying y is equal to 3x plus 2. Do learn this. Y and f of x are interchangeable. They mean the same thing. They're just showing off different aspects. Y equals is the universal code for graphing things. F of x is the universal code for I'm showing it off as a function. But they mean the exact same thing. You can always swap them anytime you like. See, as a mathematician, you have a lot of power. I mean, in a history book or in a biology book, you can just look at this and say, you know what? I don't like mitochondria. I'm going to swap that for a nerve ganglion. You can't. There's no such thing. It's this. They are what they are. Think of mitochondria. Mitochondria is like the little packages in your cells that give you energy and stuff. And a nerve ganglion is something in the nerve cell. Never mind. Basically, if it's biology, you're stuck with it. It's like, what is that thing? It's an amoeba. I don't like amoeba. I like platypus. It's an amoeba. Sorry, you're stuck with it. Here, in algebra, I don't like f of x. I want to graph it instead. Poof, it's y equals. No, I don't want to graph it. I want to solve it. Poof, it's equals 0. We have a lot of power. Enjoy it. But I want to find, I would say completely random aside that had almost nothing to do with anything. It was just a public service announcement. How do you get f inverse? What's the one step you do to find f inverse? Go. Switch x and y. Now I don't see a y here. What do you do? Yeah, put f of x, plug in y instead. Now, here's what I want you to do. Give me the new formula. X equals 3y plus 2. This is the inverse. You just have one little thing to do first. I would like you to get y by itself. Let me do that for me. algebra-wise? Go ahead. Yeah. In 2 steps you do it.
Subtract 2.
Subtract 2.
And then divide by
So hang on a second. I've got x minus 2 is equal to 3y. And then go ahead.
Divide by 3.
Divide by 3. So you should get y equals x minus 2 over 3. Or, do you remember how to simplify this, Emily? If the whole thing is divided by 3, what's another version? Go. Each one divided by 3. Or y equals x over 3 minus 2 over 3. If you really like slope-intercept form, it's y equals 1/3 x plus negative 2/3. I'll just take this one. That. Because you remember, f is the same thing as y. F inverse is the same thing as y. Just a different y. So let me start from the beginning. If you start with a function, any old function you want, to find the inverse, swap the x and y, and get y by itself, if possible. And it was possible. Ta-da. That's the inverse function. Let me prove it to you. Let's try f of 5. Katie, help me out with this. Use the regular function of f, and then plug in a 5. How do you get it?
You're using the f of x equals 3x plus 2, right?
Yeah, so what would you do?
So it'd just be 3 times 5
Uh,
plus 2.
What's the final answer?
17.
17. Does that make sense? So 3 times 5 is 15, plus 2 is 17. F inverse, what should I get if I plug in 17? Randy? If I plug 17 into the inverse function, what should I get back? 5. Let's see if it works. Actually, go for it. Use this one. I'll plug in 17. Yep, over 3. Simplify. 15 over 3, which is ding, 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 ding. It works. See how that works? Once you find the formula for the inverse function, you should be able to prove it. Because they should cancel each other out. One way to write this, I think the book's going to do this to see if you're paying attention. Do you remember that little section where we had one function plugged inside another function? I'll show you a little bit more on that later. But right now, what would you get if you plugged an inverse into the regular? What does your instinct say should happen? A regular function and an inverse. It's kind of like addition and subtraction, multiplication and division. What should happen? What's your gut instinct? That's exactly what's going to happen. What's left? X. Exactly. In other words, if you plug one function inside another function and the two of them happen to be inverses, you should get x. By the way, it has to work both ways. F inverse of regular f of x, exact same thing. These two cancel. Okay. Now, why would we need inverses? That's actually a topic I'm going to explore more tomorrow. But for today, let me show you one more thing about this. Like one last thing, I want to tell the difference between inverse versus an inverse function. They are a little bit different. An inverse versus an inverse function. An inverse is pretty much any. It exists all the time, almost. It exists almost all the time. There are a few functions that are just so strange nobody knows how to take the inverse of it. An inverse function, on the other hand, It only exists if the inverse is a function. Because when you take the inverse, you might or might not get a real function. There's a test for a function. Does everyone remember? There's one input, one output. Does everyone remember the test for a graph? Yeah.
Is the vertical line?
The vertical line test. No vertical line should hit a function's graph more than once. Remember that? Like, here's an example of a function, because no vertical line ever hit it more than once. On the other hand, if you had something psycho like this, uh-oh. This is not a function, because the vertical line hit more than once. You know, it's like, no, it didn't over here. All it has to do is kill you once and you're dead. Well, it didn't kill me 500 times. It only has to kill you once. In other words, it only has to fail once in order for the whole thing to be crashed. Everybody okay so far? Now, in other words, if you start with a function and take its inverse, it might or might not be a function when you're done. You just have to test. There is, however, a test ahead of time. And I want you to tell me what it is. Let me show you from yesterday. We actually did an inverse. We didn't know it was an inverse, but we reflected over the line y equals x. Y, go ahead and write this down. Y equals x squared. It looks like this. It's a plain old parabola, vertex at 0, 0. Over 1, up 1, over 2, up 4, blah, blah, blah. Can anybody tell me what that looks like? What did I do, first of all? Where did I get that? Okay, what do you think? What did I physically do to go from here to here? I switched y and x, which means I just reflected over what? Which of the 5 reflections did I just do? Go ahead and look at these. Switching the x and y does what? Okay, Mary, again.
Is it over the line?
It's over the line y equals x. Over the line y equals x, which means we just discovered that this is a what? Courtney. What do we call, what's a special name for when we take something, flip it over the line y equals x? The result is called a what? Starts with an I, if that helps. It's an inverse. When you swap x and y, you're going to get an inverse. I don't know if it's an inverse function or not yet. We're going to find out in a minute. Yesterday we did, yeah, go for it. Leave the little wood thingy in there so we can. Is it actually getting hot in here? It's been so long since it's been hot. Oh, yeah, it's working. Okay, tell you what, I'm going to turn this thing on. Turn this thing on. This is like a miracle. Whew. I'll leave the fan on. Yesterday we did a bunch of swapping points. This is 1, 1, this is negative 1, 1. We got this. Question, oh math people. Oh, jelly. Is this a function? No, it's not a function. It's an inverse, but not an inverse function. See the difference? You can invert almost anything, but the inversion might not be a function when you're done. How do you know it's not a function? Jelly, what?
It doesn't pass the vertical line test.
Right, it doesn't pass the vertical line test. The VLT, not to be confused with bacon, lettuce, and tomato, fails. I think veal, lettuce, and tomato or something. Yeah. The veal is nice and lean. Princess fried. So the vertical line test fails. Do you notice that the thing got flipped? Like, this is the y, like, would you know what I meant by this is the y positive direction? Like, that's where all the positive y's are, up. This is where all the positive x's are. And if you swap the x's and y's, then the positive y's are really gonna be replaced by positive x's. That make sense? And the positive x's are replaced by positive y's. X and y trade places. So if you're talking about y's, all of a sudden you're talking about x's. Here's a hint. Somebody hundreds of years ago thought of this. This is actually rather ingenious. There's a test ahead of time to find out if your inverse is going to be a function or not. And it's something where first-year algebra students sometimes ask me this. After they first learn the phrase vertical line test, can you guess what one of the most logical questions they'd ask after that is? Is there a what?
Horizontal.
Is there a horizontal line test? And I say, not yet. Until now. The horizontal line test, if you pass the horizontal line test, the inverse will be a function. You don't even have to do it. If you know for a fact that the graph of the original function passes the horizontal line test, which by the way it doesn't in this case, then you know that your inverse is going to be a function. You don't even have to do the math. You just say, there you go, function. Clear? The book is going to be asking you, here's an example. Does the inverse function exist? The book, I will also warn you, is getting sloppy. It will say, does the inverse exist? That's a horrible way for the book to write it. Inverses exist almost all the, see, this exists, but it's not a function. When the book says, does the inverse exist, what they're really asking is, does the inverse function exist? Is it a function when you take the inverse? I like the book, but this is one particular chapter where it really irritates me. Their terminology is wrong. It should be inverse function, and they just keep saying inverse. Why? Because somebody was lazy, or I don't know. Maybe English wasn't their first language. Who knows? But, for example, if g of x equals radical x, does g inverse of x exist? Now, this is what I would call book speak. For does g inverse of x exist as a function? Because almost every inverse exists. I want to know if it's a function. How would you find out? There are usually two ways to find out whether an inverse exists. One is using the formula, and the other is using the graph. What do you think?
Well, we know what the parent graph looks like.
Okay, what is the parent graph, by the way?
It's half of a parabola.
Which half?
Like
Upper, lower, left, right?
left or right. But sideways.
Sideways, okay. Where does it start?
At 0, 0.
At 0, 0. Give me the first pattern jump.
Up 1,
Other way
over
around.
2.
Over?
Over 2, up 1.
Not quite. Over 1.
Over 1, up 2.
Up 1.
Over 1, up 1.
Over?
2, up 4.
Very close. Other way around.
4, up 2.
Over 4, up 2. Yeah. Over 1, up 1. Over 4, up 2. Over 9, up 3, etc. This is g of x. I agree, the function graph is going to be very useful. Can anybody tell just by looking at the graph if the function exists? Inverse? I mean, everything has an inverse, but is the inverse a function? What do you think? Why?
Yes, because it passes the horizontal line.
The horizontal line test passes So in other words, the answer is yes, because the horizontal line test passes. That's all you have to say. You're done with the problem. I'll show you the graph, by the way. Swap the x and y, swap the x and y, and it turns out you get the right-hand side of a normal parabola, which is a function. Do the vertical line test and good to go. Does that make sense? Alrighty. That's about all I have for you. So you get about 12 minutes, you can start pounding away at the, remember there are two little parts to the homework. The last two questions for homework 4C, 31 and 33, and then 4D, which is on the homework guide sheet. So just two things on symmetry. That was on even and odd functions. And then the other ones which are moving and resizing, which should actually be pretty fast. So 4D shouldn't take a huge amount of time. Last questions. All right. For the first time in 2 weeks, I'm actually taking off my blade. This is good. So go to it. Call me if we get stuck. Yeah, sure. Oh, okay. Thank you. Yes. Okay. Got it. Thank you. Anybody else have homework to check off from the other day? Oh, I see. I see. Okay. Thank you. Anybody else? Make sure the little block stays there. And, oh yeah, I can stop recording. Okay, for those of you listening at home, I'm sure the last 2 minutes was really boring, but this is my hand waving goodbye. Talk to you later. Oh, and by the way, the assignment, in case you missed it, is, ta-da, homework 4C, 31 and 33, and homework 4D in its entirety, due tomorrow or whenever you get back. So take care. God bless. Bye-bye.